In this video, you will learn about the Pythagorean Theorem. Before we do anything, let's learn some vocabulary. The hypotenuse is the side opposite the right angle of a triangle. So there's a really small triangle here. I don't know if you can see it, but here would be A, here would be B, and then this right here, this is the hypotenuse, the C. All right? Okay. Next is the Pythagorean triple. This is really important in this lesson, so pay attention. It is a group of 3 counting numbers, so like 3 normal integers that satisfy the equation c squared equals a squared plus b squared, or a squared plus b squared equals c squared, where c would be the greatest number. This is an example of the Pythagorean theorem, all right? So say we had a is equal to 2, so like this side would be equal to 2, and this side would be 3, that would be b. Then what does the hypotenuse, or c, equal? So then we'd square everything. A squared plus b squared equals c squared. So a would be 2, so we'd make this 2 squared, and then b is 3, so this would be 3 squared, and equals c squared. And based on that, we can figure out c using square roots, right? So 2 squared is 4, 3 squared is 9, 4 plus 9 is 13, and the square root of 13 is 3.6, and that's how the Pythagorean theorem works. Let's try a few examples. Find each missing length. All right, so we have A and B, and we have to figure out C. All right, so let's see. 8 squared plus 12 squared has to equal C squared. And 8 squared is 64, 12 squared is 144. So 64 plus 144 is, my mental maths are not good, $208. Alexa, what's the square root of 208?
The square root of 208 is 14.4222.
All right, so you heard her. 14, well, here would be 208. But c would be equal to the square root of this would be 14.2. All right, so our c is 14.2. And here, let me think of a problem. Well, this would be b, and say this was, we'll say 144, and then this would be 2. All right, now here we're missing b. So out of a squared plus b squared equals c squared, instead of missing c squared, we're missing b squared. So let's do this again. 2 squared plus, instead of a normal number, we'd put b squared, is equal to 144 squared. And what is that? Alexa, what's 144 squared?
144 squared is 20,736.
20,736. Now that's a big number, but you know, oh, I didn't write that here, but it's a big number. So we'll put 4 plus b squared is equal to 20,736. All right, so now again, isolate the variable. Minus 4, this would be 20,732, which is again a big number. So Alexa, what's the square root of 20,732?
The square root of 20,732 is 143.9861.
143.9861, which would be, we'll just put 98. All right. So here's our answer. Now, it says determine whether each set of numbers form a Pythagorean triple. Now, I don't know if you remembered, but in the beginning of the video, I said that the Pythagorean triple was a group of 3 counting numbers that satisfied the equation a squared plus b squared equals c squared, and c always had to be the greatest number. Otherwise, it wouldn't be known as a Pythagorean triple. All right. I know you see square roots here, but don't freak out. It's really simple, actually. When you square a square root, what do you get? The actual number, right? So it's really not that big a deal. So let's see what forms a Pythagorean triple. All right, so this is in the order ABC. So it should be 3 squared plus 2 times 10 squared. So 10, so obviously we're gonna square this, right? So 2 times 2 is 4, square root of 10 squared is 10. So 10 times 4 is 40. So we'll just put 40 here. Is equal to the square root of 41 squared, which is 41. So 3 times 3 is 9. So 9 plus 40 equals 41. Now already you can tell that does not satisfy the equation. It doesn't even equal. So first of all, it can't be a right triangle. And second, it cannot be a Pythagorean triple because it does not form a right triangle anyway. It doesn't satisfy the equation. This would be 49 equals 41, and we know that's not true. Let's do B. All right, so we got 36, 77, and 85. All right, so 36 squared plus 77 squared equals 85 squared. Is that true? We'll find out. Now notice already, this goes in order, 36, 77, 85. C is the largest number. So we'll see if it actually is a right triangle, because now it just depends on that. Alexa, what's 36 squared?
36 squared is 1,296.
Alexa, what's 77 squared?
77 squared is 5,929.
Alexa, what's 85 squared?
85 squared is 7,225.
All right, let's see if this satisfies the equation. So 5,929 plus 1,296 would be 9 plus 6 is 15. 9 plus 3 is 12. 9 plus 3 is 12 again. And 5 plus 2 is 7. And we get the number 7,225. And therefore, this would be a yes. It is a Pythagorean triple because A, it satisfies the equation a squared plus b squared is equal to c squared. And B, c is the largest number in both areas. So, yep, we're all good. And that is the Pythagorean theorem right here. Let's try a word problem. It says, Larry is buying an entertainment stand for his television. The diagonal of his television is 42 inches. The space for the television measures 30 inches by 36 inches. Will the television fit? Now, let's take a look at this. Let's read it, right? So it says he's buying an entertainment stand, all right? And the diagonal of his television is 42 inches. So that means this is 42. It says the space for his television measures 30 by 36. So he has space enough for 30 inches by 36 inches. Will it fit? Okay, so to do this, basically, say this was the television, and that's its diagonal, and the diagonal is 42 inches. Now, Larry has a space that measures 30 inches by 36 inches. So will it fit is what they're asking. Well, I guess we'll have to see. This 30 squared plus 36 squared, enough for 42 squared. All right, let's see. 30, Alexa, what's 30 squared?
30 squared is 900.
36 squared? Alexa, what's 36 squared?
36 squared is 1,296.
Alexa, what's 42 squared?
42 squared is 1,764.
All right, well, forget the equal. It has to be greater than or equal to 42 squared. Now, if we add up 1,296 and 900, we're left with 2,196. Now, does that equal 1,764? Well, no, it doesn't, but that just shows that it's big enough space for Larry's TV to fit. And there you have it. That is the Pythagorean theorem. There are a few links that I posted below in the description if you would like to check them out to, well, get caught up on this and practice. So I hope this video was worthwhile. Thank you.